Hey guys, Avengers Endgame has come into theaters last week, so I thought I'd take the opportunity for a Fusion particle tutorial, and I think you know which effect is coming now. Yes, this one. This effect has become quite popular, and I think there are around a dozen or so tutorials out there, and practically all of them use After Effects, and most of them use either stock effects pre-built or they use Trapcode particular. Now, of course, these tools have a good price tag, and everything I can do here can be done with a free version of DaVinci Resolve or with Fusion Standalone, so I think it's a good time to add some Fusion magic into the Thanos disintegration effect. I will start this tutorial by talking about the basic idea and my setup for this effect. Then I will go step by step and create a rudimentary basic version where you can follow along if you like. And then I will give you all the tricks and tips and techniques that I'm using to bring it towards the final result that you see here. Creating the full version of this effect is probably a bit more on the advanced side, or at least it can get quite time consuming if you want to do like everything that is possible, but creating the basic version, even if you're a beginner to, let's say, intermediate user of Fusion, should be possible, and I think there's a lot that you can take out of from the workflow and the principles that I discuss. That being said, let's dive in. Quick note, if you want to follow along with me, you can go to my website VFXstudy.com and download the full package with my footage and Fusion comp and everything. No registration required, nothing, just download and you can use it as you like. While you're there, if you do decide to sign up for the newsletter, I am currently working on a full course for Fusion inside Resolve 16, and I will notify you once it gets out. Now, coming to the effect, I am currently in Fusion Studio version 16. Everything I do here you can do exactly the same way in DaVinci Resolve. The reason why I'm in Fusion is that it's easier for me here to do test renders rather than via the deliver page from DaVinci Resolve. And also I know that I will be working on this effect for quite a while, so I prefer the stability and simplicity of the standalone version rather than all the editing and extra capabilities of Resolve. Now coming to the effect at hand. What do I actually need? I need basically three things. I need a clean plate, meaning I need to have my background without me. I need a rotoscope of myself, and I need the particle effect. First of all, clean plate. I am in a quite simple scenario here because the camera is on a tripod, so all I need to do is get out of this chair and I have the background without me. So here it is, the clean plate. Let me do a quick A/B comparison on a separate window. You see this is the clean plate, this is with me, so it looks mostly fine. There are a few issues, so on the one hand, there is a shadow in the background. I'm casting this shadow, and I'm casting a shadow here on the keyboard, which is going away. But then again, if I go away, the shadows maybe should also go away, so that's not bad actually. Unfortunately, the mouse moved a little bit by accident, and the chair moved up. So that part is a bit undesired. I did know about it when I created the video, but I first thought maybe I could do some funny effect with the chair rotating or jumping up or something like this. Didn't really work out and didn't look so great, but I also knew that I could easily hide it just by zooming or by putting particles over it while it's transitioning. So all in all, I'm satisfied with the clean plate. Now coming to the removal of the foreground, I'm using rotoscoping here. Now you can use green screen if you have one, but then you need to take care of spill and need to think about background shadows and so on and so on. I'm using rotoscoping, which is actually not that much work here because first of all, I'm hardly moving in this sequence, and second of all, the rotoscope doesn't need to be perfect because a lot is being covered by the particles. and it also needs to be good in the places where the particles are generated. So I can be very selective with this effect, and I don't need to do like 100 frames of perfect matching rotoscope. Now, just a few tips. If you decide to rotoscope yourself, you have basically two tools here. You have the polygon and the B-spline. This one is good for smooth areas. This is good for rectangular and edgy areas. Let me make a little bit of space here and just do a little bit. For example, if I want to rotoscope my shoulder, I would maybe start with the B-spline here. And generally, you should think about joints. You should think about areas which are moving. Since my upper body is hardly moving, I would start maybe on the left side with a shape something like this, just quickly. So this could be my first shape. I will never do a rotoscope which just goes all around, because this is almost impossible to handle. What you want to do is you want to keep shapes simple. You want to keep shapes which themselves don't twist or transform, so that you don't need to go into changing individual points, but you can just move whole shapes. So it's never a problem of having too much shapes. You can make like 10 shapes like this or 20. That doesn't matter. The point is you want to animate as little as possible. That means you don't want too many points. You want the points so that you can somehow control them. So at areas where you can find them and see them, so that these points are solid. Like this one should be above this fold, and it should be throughout the scene above this fold, even if later things change, right? So you don't want the points to shift around, and you want to animate. You want to keep your animation minimal, so that you can easily do corrections later. If you have 100 keyframes and then there's one point which is not matching, then you have to go through all the keyframes and try to fix it again, and then you find some other point is not matching and so on. So thereby you can really go crazy. So don't do this. Instead, make simple shapes like this, and then if you have to animate them, take the whole shape and move the whole shape at once, either by animating the center, right-click, animate on the center, and then if I need to do a correction, let's see if I even need to. Yeah, here maybe I want to bring it a bit closer here, then I just move the center coordinate, or I just mark all points and move all points together, but I'm not really starting animating individual points if I can help it. Now I have one shape here. I can just select this shape and then add the next one. Let's say I want to take the lower arm here. I can just maybe take a polygon, for example. Sorry, if I selected the previous one and then click it, it should be automatically, yeah, it's automatically being linked together. And now I can do the lower arm. The shapes can overlap, no problem. So I take a polygon here, which is a bit straight. I pick some points which are recognizable. So inside, I don't care, this will be overlapping. Here I have, if I want to smooth a point from the polyline, I can press Shift S, and then it gets smooth. So I can make it match perfectly. And if I want to change like the curvature a bit, I can do it like this. So this way I can really use very few points, which is easier to handle and make the shape pretty good. Again, doesn't need to be perfect. Actually, I'm probably much more detailed here right now than needed for this effect. Now, if I bring the masks together here in the viewers, then you can see just by adding, they automatically get like overlapped and combined. This is because here the paint node says merge. This is the default. So this way I can continue covering me with different shapes, and I get the full rotoscope. Now, again, how detailed you have to be really depends. I can show you what I built up front. I built this one, which is fairly detailed, and let me actually connect it. And let me connect this to the let me mask out the foreground with this. So I get this foreground here, and you see it's quite detailed, but if you look in detail, you will see there's some wobbly motion here, and of course there's no way I'm gonna rotoscope hair, so I just cut it off and so on. But then again, you will not see this at the end. So depending on what effect you do, you can get away with something much worse with this. If your particles just blow in all directions, then basically the rotor almost doesn't matter. You just need some place where you start your particles, and then everything else will be hidden behind the particles. This one is fairly detailed. What I suggest is start with something you can create in 10 minutes or so, and then create the effect, and then see how much detail you actually need. I will not spend the next 1 hour of this tutorial by rotoscoping, just to show you the final result that I did here before. So you see I named the different rotor splines based on where they are, so I can easily change them later. Each of them has a few keyframes, again probably more than I need, so I did my arm here. You see the individual shapes and something which just fills the body. So again, take the main parts of your body, or the main shapes, any joints that are moving, you might want to do separately. So you have an upper arm and a lower arm. The hand moves a bit more, so that's why I took the hand from the top, and then from the bottom, and sorry, where is it? Here. And moved it individually. Also, I did some tracking here. I was actually able to track my hand and track a rotor shape. Well, again, you can spend a lot of time on this. You can do a lot of things. You don't necessarily need to. For a basic effect, you can get away with a much rougher shape. So much for the rotoscoping. Now let's see how I can build a particle effect from this. Okay, now I have cleaned up a little bit. This is my starting position now for the particle effect. Now what I need is something that generates the particles, which is either a particle emitter or a particle image emitter. These are the two tools that create particles. Then I need a particle renderer. And then it depends whether you work in 2D or in 3D. I'm working with 3D particles, so I need to put the 3D particles into a 3D scene and render from this 3D scene. So let me quickly set this up. If you're looking for the tools, you can find them under Effects, Tools, Particles. So particle emitter is not the image emitter, I want the regular one. And I tell you why in a second. Then, so a particle renderer, this one you always need, otherwise your particles won't do anything. And now the particle renderer can either work in 3D or in 2D. If it works in 2D, it directly generates you an image. If you want to work in 3D, what I want to do here, and which is the default, then it renders the particle into a 3D scene. So now a 3D scene requires a renderer again and a camera. So what I will do is I will add a 3D merge here, which is here, and a renderer, which is this tool, and a camera, which I have here. Now the camera should go into the merge, and I probably don't see anything. But that's fine. Let's see what the particles are. Now in the particles, typically what I do is first increase the number a bit, so there's a chance we see anything. And the second part, which I typically do, is I don't work with point particles, because point particles are almost impossible to see. They are like 1 pixel thin, and they can be very useful, but what I typically do is I first work with some blobs or something bigger until I know that I have my general arrangement right, that I have my motion right, and so on. And if I want later, if I want points, maybe I can crank up the number to some insane value and do that at the end. But just for working, I typically go to my style here, and let's use an n-gon in this case, and something solid maybe, and I don't want something with 5 edges but with 4, And now I really want to see where I am here, so let me actually check the particle render here and close this. So now something very starry came here and big. So let's reduce the size of this in the emitter. I have size controls, and maybe I increased the number too early. We can do that later. Now you see let's go to frame 0. So you see I created some stars here, but this n-gon can not only create stars, it can also create rectangulars. There's this parameter starriness, which sounds funny, and you can get everything from stars to blobs, and I want something that's close to a rectangle. Now here I have some particles. Now how do I get the particles to match the image? First of all, I can get the overall shape, and then I can get the color as well from the image. Now you may be thinking there is this particle image emitter. What the particle image emitter does, it creates a raster, and by default for every pixel of the image you get one particle in a perfect rectangular raster, and these particles remain aligned to the image. I did work with this before for this effect. There were 2 points why I stopped using it for this particular effect, and I can show you why. First of all, the problem with the p-image emitter is that the image remains linked to the particles, meaning I have a video, so a video has noise and the image is changing, and on the boundaries where I'm moving my hand or so, my masks are changing and my transparency values are changing, and that means the particles after they are created still change with the image. Now there are maybe ways around that by basically using freeze frame for the particle generation. But this was definitely one issue why the particle image emitter didn't work that well. And the second issue was just because it takes the image for every frame, or the video sequence for every frame, it also takes a lot of computational effort. And this one here, it was much easier to handle. The only problem now is it's not that intuitive to get the image onto the particles, but it's not that difficult either, and I show you how you can do it now. So if you use the regular particle emitter, you can go here to the region setting that exists in practically all particle tools, and you can decide in which region this tool should be active. And here I can choose bitmap. Now that means that I am using a bitmap, meaning a 2D image, to define the region in which this tool is active. And here active means particles are being generated. So let me connect the foreground now to this tool. Since I selected bitmap as the region, I now have an input here to the particle. This is there because I made this selection. Now I have linked the image. And if I now see here in 3D space what happened, now I definitely need more particles to see what's happening. Let me increase the number even more. 200, 2000. Yeah, there you have it. So you see that my shape is being used. So from the bitmap, the alpha channel is being used as the region that I'm defining for the particles. I can use this now for the animation and so on, but let me also get the color right. So to get the color, I can go into the particle emitter, and here it says color, use style color, and style color is what you define here. So if you want the particles to be brown or some ash color or so from the beginning, you can define that here. You can also define with color over live, can make them change into a darker tone and so on. What I preferred actually here in this, for this particular effect, is not to use this, but to use the image itself, so that the particle really look like they're coming from my shirt or from my skin or from my hair, right? So, and to get this, I can not use style color, but use color from region. And there you have it. Now it's myself mapped onto particles. Pretty good start. Next thing I might want to do is animate them and move them away. And I need to make sure that my particles are being generated in some clever way. Now the question is really, how do you want them? Do you want to create all the particles in the beginning? Then you can just use frame 0 with a high number of particles and then animate this parameter at frame 1, make the particles 0, and then animate them to disperse or something. Or the alternative, what I want to do is actually, I want to kind of dissolve myself step by step and create the particles only where I'm being dissolved. So to do that, I create a mask which does exactly this effect. Now let me do this a simple way. Let me create just one simple mask which just moves up and removes myself from the image. So let me use a B-spline for this. I'm creating one mask which, let's say, is a little bit wobbly so that it doesn't look too artificial. And this mask I want to move up, so let me pull it down so I have some space here. You can press Shift L if you want points to be linear. Anyhow, and this mask I want to use to remove parts from this picture. So for this I should multiply this mask. So this is what it looks like. Should multiply it with the original mask or with this picture. And to do this here, there are lots of different ways to do this. What I like to do is I just like to add channel Boolean nodes for this. Now you can use merge, you can use transforms, there are different ways. I use control spacebar Boolean, I find my channel Boolean. This is basically a channel logic operation. Sounds a bit complicated in the beginning, but it's actually very simple. So the operation I want to do here is multiply. And if I do multiply and attach the masks to the foreground, then what happens is that channel by channel, what is coming from the background is being multiplied with the mask, and my output is what I have masked out. Now I wanted to remove and not add, so I should probably invert this mask, and this way I'm removing. Now let me animate this mask over time. So at frame 0, I want this mask to be out of the frame. Let me animate the center for this. I just animate the center parameter to be just out of the frame. And then let's say at, I don't know, frame 90, let's say, I want myself being completely removed like this. Okay. So before I continue with the particles, let's do a simple trick to see how this looks like in 3D and how it looks like over the final background. So for this, I will add another object into my 3D scene, and I will just add a plane with the image of myself projected onto the plane. So for this I have a image plane 3D is the name of the tool. Again, you can find it under effects under the tool sections. And I'm adding myself onto that image plane. Now I have myself in 3D. And of course the animation now takes place in, well, 3D. And let me see the render, and I don't see anything, and that's because of the camera position. So let me fix that as well. And for now I will just deactivate the particles. So let's just stick to the image plane here. I deactivated the particles, and where is the camera? It's in the middle of the scene, of course. So I need to move the camera back and further back until it matches. Probably I can zoom in, or actually let me move myself over the background to see if everything is aligned. So I'm moving over the clean plate, And if I bring this into the view, I can now see, yeah, so actually this looks pretty well aligned. And I can again move the camera to make it match perfectly. Okay, so now I have the rotoscoped version of myself sitting on the chair of the clean background. Now if I play the animation, you see that I am being removed from the background as time progresses, like this. Now what I want to do is I want particles to come in exactly as I'm being removed. So for this I can actually use this mask here. Just look at the alpha channel for now. I can use this mask and I see that this is shrinking, and what I want to do, frame by frame, I want exactly the part that is being removed. I want exactly that part to generate particles. And the easiest way to get the particles exactly where the mask is being removed, is to use the current mask and the mask from one frame earlier and combine these two. I can actually achieve this just with a simple subtraction and a time stretcher tool. Now I just have to pay attention to which mask I'm using. I should probably not use the mask which is masking myself, because my hand is moving and so on. So from one frame to the next, that will not line up. But the mask that I'm using to subtract, that mask is fixed. I didn't animate that in shape. I just move it up the picture. So I can use that mask to get this one frame difference. This is this B-spline here. And I have a tool called a time stretcher, which I can use for this. Control spacebar, time stretcher, no, time speed, sorry, time speed, I believe. Yeah, this is the tool. This has a delay parameter. Let me connect it and look onto it on the second screen. So let me bring them in full size. So this way they move side by side. Now if I use the delay, you see that with minus this one is moving ahead of this one, and with plus it's moving behind. What do I want? Plus or minus? I want plus. I want a delay of 1 frame. Let me type it. 1 frame delay. And now I can subtract the two masks from each other. Let me add a channel boolean again. Again, boolean, merge, whatever is your preferred tool. I add, sorry, I have to pay attention. By default, it takes the mask input, but I want the background input and the foreground input. And now if I use subtract, let's see what happens. I get blank. And this is because I'm subtracting from the white area, which is 1, which is bigger than the other one, the part that I'm actually carving out. So instead of subtracting the foreground from the background, I can switch the two tools, Control T for switching background and foreground. Now I have switched them in my subtraction operator. And now if I look at it, now I get the difference. So what I have now is I have a boundary here, which is just the 1 frame difference of my subtraction between current frame and last frame. And this 1 frame difference I will now use for my particle generation. So instead of connecting the full, subtracting the full tool here, I will use this one here into my channel boolean. And here I don't see much, but I see basically the part of my image which is being affected by this mask comes here into play. And if I now activate the particles again and look into it in the 3D view, let's directly we can look at the render as well. And sometimes you see these kind of effects where I made one mistake here. I changed the logic here for my particles. Okay, let's look at the particles first, and then I have to fix the image plane. This one currently doesn't make sense, so let me actually remove that for the time being, and let's just look at the particles. What you see now is that frame by frame, my particles are being generated, and it's taking a very long time to render for me. Let me pause this and check again the particle emitter. Now I'm creating 2000 particles per frame. That was fine to see in the beginning, the picture on the first frame, but now I'm actually creating it in slices, so I want much less. So let's just create, let's say, 50 or just 20 should be enough. And now my playback should be smooth. Yeah. So I am frame by frame, slice by slice creating particles. And now these particles should be there where I removed myself. And for this, I already had that before. Let me restore that. Now I changed the logic here. Let me copy this node and use the B-spline as I used it before to subtract, and I can add this again to the, sorry, let me move it down to the image plane here, and the image plane back into the 3D. Now I'm creating particles exactly in the place where I remove from myself. And the particles have limited lifespan, that's why they disappear again at the end. Let me fix that particle emitter lifespan. I am using 150 frames. Anyhow, it doesn't matter, they just should be staying till the end. I can just make it maximum or whatever. Now the particles will stay with me till the end. Now I will start with the animation, and then you will also see why I am working completely in 3D. I'm using 3D particles, and I projected the rotoscope version of myself onto a 3D image plane. And the reason for this is that now particles can, in 3D space, move before and behind me, behind the parts that are not yet dissolved. And this way I get a little bit of more depth into this effect. Now, of course, in a perfect world, I would have a 3D character model and be working entirely in 3D. I'm pretty sure that's how Marvel is doing it. But they also have ready-made 3D models for all of their actors and 3D scans and so on. And they have slightly different resources at hand. But for the homemade version here, I'm just trying to get as much 3D as possible into it with these little tricks. To animate particles, you basically use forces and you use initial settings of the particles. So at the time of creation of the particles, you can decide what they should do, and you can start them out from the creation with an initial velocity and certain random parameters and spin and so on. So that's a good point to start. Then they will continue moving like this from the initial velocity onwards, and then you can apply forces. The most common ones for me are a directional force, which just accelerates them in one direction. Turbulence, which makes them, turbulent, fly, disperse, and so on, and gives more random behavior. And friction is often quite useful. Now, there are a lot of other tools in the particle library. If you just look into the particles, you can see a lot here, what you can do. Point force, you can merge particles from different systems and so on and so on. If you're starting out, start with those. Start with the initial parameters, give it some directional force potentially some friction which slows them down again or counteracts the directional force, and some turbulence to make it more interesting. If you start with this, you're already have the tools for quite nice and interesting effects. So giving it some initial settings, let me go into the emitter again. Here I have the velocity settings. So I give my particle some initial velocity. And I always give variance because I don't want everything to look like, you know, mechanical. So if let's actually also see how it's doing. So like this, maybe that's already fine. And maybe I give, as variance, often I use either the same value or half the value, or depends on how much variance you want, something less. So now you have some particles that move faster than others. To see it, let me move them here into the empty space. I can do this with the angle here. So the angle, the x angle 0 is moving, should be moving right. Yeah, so at the moment they're all moving to the right at angle 0. So 90 degrees is upwards, 45 should be around the diagonal, or a bit less than 45. So if I move in this, yeah, now I should see them move upwards. Let's see. Yeah, now they're moving towards this corner where I have some space. Let me actually make it a bit bigger. And again, always like some variance, so it doesn't look too mechanical. Maybe half the angle. Z, now we want to be in 3D. So at the moment, if you see in the 3D viewer, we are all in one plane. Now if I add some Z angle, let's say I want them move a bit back, then I don't know, is it plus or minus? Sorry, where's the camera? Here's the camera. Okay, minus seems to be pointing backwards. Not too much, just a little bit. Let me actually type it. Sometimes these controls are a bit tricky. But now I want to do enough variance so that some are actually coming to the front. So I will make the variance quite big. So let's say 20. So I have a variance from -10 until +20 and -10 until minus. So it's from +10 to -30 if you combine the angle and the variance. So this way I should have some particles moving in the front and some in the back. Does it look like this? Not much to the front actually. What if I increase this even more? Okay, now I get some into the front. Okay, yeah, so I have some moving, and it seems like they are moving up, but they're moving at the same speed as I am dissolving. So maybe I want them to move a bit faster. Let me increase the velocity just a bit. It's so that I'm getting some particles actually in front of me, and the variance maybe as well. Okay. So now you see them moving to the side, and some are in front of me, some are behind me. Now it can be hard to see this if you're just in a quick animation. Maybe you don't realize that something is in front, something is in back. But even if you don't consciously notice the individual particles, you still get an overall impression about it. And I think the subconscious or overall feeling when you see a clip like this is impacted by these kind of details. Okay, now my particles are already moving. Now let me add turbulence so that they don't all like move in one stream. And for this, P turbulence, Control spacebar P turbulence. There I have it. And let's see what happens by default. Not much. So perhaps I need a bit more. Let's just crank it up. Yeah, this looks more like it. So you have, yeah, now you see them, maybe even more. Let's just bring them all. Well, you can play with the parameters. Maybe that's too much. And then especially when you have more particles, you can sometimes see these kind of strings or streams or things swirling around. It also depends on the density. So the strength is how strong the particles are affected, and the density is whether the turbulence are happening on a big scale, like like big worlds, or whether on tiny spins. And the best way is always to just try out and see how it looks like. So this is with a higher density, or even higher. Now I can hardly see it. Small. Then I think you can see the spin a bit more. And it will be more visible maybe if you add more particles. But then again, if we add more particles, then also it's more difficult to have the live interactive feeling here. Okay, but for explaining the tool, again, you can spend hours with these kind of parameters. But just for getting a general impression, this should be good enough. I mentioned the directional force and friction. So if you don't want to accelerate your particles from the beginning, or if you want to accelerate them later, let's say you want some wind or some whoosh effect or something come through the scene, what I would do in that case is just add a directional force, P directional force. There we have it. And I can animate it immediately. Let's make the strength 0, so it has no effect. And let's say everything should go until maybe here. And then I want some force to have them push out of the frame. Then I animate here and go, let's say, a few frames forward. Actually, I can just give one kind of impulse. Let's give over 5 frames or so. I go to full strength and then stop it basically. Next frame again 0. So let's see how that looks like. Hardly noticeable. So either I need a longer duration of my push or a stronger push. Let's go for the stronger push. Still not much. Actually, I should go for a longer duration because I want all particles affected. So maybe I should go until I'm fully dissolved, and then push. So to change my keyframes, let me go to the keyframes here. I hate this window actually. If I do F4, I can at least get the full size here, and I can, under here, I can show only selected tool, which is the wrong one. Sorry, I need to select it. Where is it? P directional force. This one I wanted. And where is my strength? Should be here. This interface here was much better in Fusion 9 actually compared to Fusion 16. It's more difficult to navigate then. That was kind of feels like a step backward. Well, I am in the beta version. Maybe it gets better soon. Let's see. But it still works. So I wanted to come quite a bit out till, oh, I'm pretty close till this point. And maybe I start a bit later as well. So this way I can move my keyframes. And okay. And my directional force is going -90. Actually, I wanted to go, I think I wanted to go to 0 if I want to move it to the right, because otherwise my directional force is working against me. Yeah, there we are. So now I have a push to the right, and maybe even more let's just double it. Let's see, 0.4. Yeah, so this way I kind of push my particles out of the frame because I have very strong sudden winds in my office. Okay, good. Last point, friction. I don't think I need it here. Typically, if you use directional force over a longer period of time, as long as the force is active, the particles are getting accelerated. That means they get accelerated and so on, and it doesn't stop, right? So if you have a particle moving to the left and acceleration to the top, then you get like a curved particle trace and stuff like that. If you want to limit that acceleration, then friction is usually a good thing. Also, if you have particles moving fast in the beginning and you want them to kind of slow down a bit, like, I mean, explode in the beginning and then have the ash fall down or something like this, then you should experiment with friction. Let me keep this for the basic animation. Not yet the Marvel kind of effect, but a good start, I think. For a few very simple steps, I might want to change in the emitter. I can crank up the number of particles once I'm satisfied. Maybe instead of 20, do, I don't know, 80. And I can change the size. I can have some size variance here. So at the moment I have 0.1. Let's actually make it smaller. I make the size like half, 0.5 maybe. And at the same time give some size variance of maybe also the same or so. So this way my particles, you know, don't look all the same when they're created. And also they can spin. So under rotation, here you have spin. So I can just give a little bit. I don't think I need much, but we'll see in a second. Again, wherever I put something, I also put some variance so that not all look the same. I let them spin in all direction. But if I remember correctly, the spin is quite aggressive, these parameters. So let's see how it looks like. Now they're almost too fast. Or maybe too small. Okay, so we can add more size variance. Size variance. Let me make the size variance actually even bigger than the size. So we get some big particles and a lot of small. Yeah. Okay, and then a lot of particles and some color effects and so on, and then we are getting close. I will save this now as the basic version, and I will open the final version now, and I will tell you about all the different tricks and what I did in order to come up with my final version. Okay, this is my full flow of the final composition, and before I dive into it, let me show you again the full thing in full screen and pause a bit to show you a few things. First of all, you can see that I have all my hair here, so I am not using the rotoscope version, but I'm using the original plate here, and I blend in the rotoscope version only where I'm actually applying the effect. So the rotoscope version with the not so great edges only comes into effect here where the effect is actually happening, but not on the rest of the picture. Second of all, if you look at the shadow in the background, you also see that I'm blending it over. So I'm blending, and here the shadow is gone now. Same on the keyboard. So in the beginning, the shadow is there, and here I'm blending over to the final version. Of course, the chair, the problem is still there, and I will just mask it by zooming at the end. I'm working in 4K, by the way, in the real version, so I can zoom. Another thing here is I have massively more particles, as you can see, but not just more particles, but particles of different kind. So I am using these n-gon square particles that we used now in the basic version. I'm also using point particles. You can hardly see them, but if you look closely, or even if you don't see them, you might notice them. They're like tiny little dots here. Maybe here on the black you can perhaps see them. Also, there are some big particle n-gons in the background. And so what this is, there is actually a layering happening here. So I have particles coming up from the front, and then I have darker particles from the back. Speaking of lighter and darker, you can also see that the particles don't have exactly skin color, but I'm desaturating. Even more so, before the particle effect happens, I have a little texture crawling over me, so that I'm introducing like this kind of falling apart desaturation texture thing, where like my skin turns into ash before it turns into particles. And then once it turns into particles, the top layer of particles is already a tiny little bit darker than this textured part here. And then if I go further, I have a bottom layer in the center, at least, not under the arm, because there I wanted only smaller particles. And then when I come to the main body, I have bigger particles which are in the background. And at the end, I extended the scene, so I still have some particles swirling around, perpetuated by the turbulence. So I have like these single particles floating around. Now let me show you what this means in the flow. So let's go step by step. First of all, I have starting from my clean plate. By the way, I'm working in linear space. That's why I added this gamut tool. If you don't know what that means, don't worry about it. You don't need to do it. Basically, I'm working in 16-bit float linear space, but it's not really necessary for this effect. Anyhow, it doesn't matter. There's a color correction on the background plate. Let me make this a bit bigger here. So you see that the shadow here, I'm faking a shadow, which is then being phased out over time. So that's what this is doing for the background plate. You see here polygons, and these are, let me show you in the big view. So they start out black, and then I'm doing some mask like this. And basically these are merging between the foreground and the background. So this is the real foreground without any masking. And if I go over these here, actually this is not entirely the real foreground, but these masks here only control the background area. What is happening in the foreground happened once before. That happened here. So what I'm doing here is I'm using my rotospline to merge the clean plate background over the foreground. So instead of putting myself over the background, I'm actually removing myself from the foreground by inserting the clean plate here. And here you see the problem because of difference in the shadow, but this part will be behind the particles, and it will be again cleaned up by these masks one step later. So if I look into this here, you see that these masks actually remove the artifacts from this procedure here. So here I have clean plate, original plate, clean plate being moved over, and then afterwards I have here the transition between, again, original and clean plate by removing these artifacts, masking them out. So yeah, removing myself instead of adding myself, that's one effect. I'm still adding myself into 3D space, but now I'm adding only the effect version. So I'm not adding the full version. I'm adding it for effect only. So for the particles can still go behind and before me, except for at the boundaries it will not be accurate. So wherever my rotor is not be accurate, it will also not be accurate at the end. But whether a particle moves like before one strain of hair or after, nobody will see. So I don't care about this. But for the whole picture, it's still accurate. So if I look into the effect preparation, I do some 2D preparation first. So my original mask, where is it? Now this flow got a bit confusing. Sorry about that. So here I have my mask my cutout piece the same way I did it in the basic version. But this cutout piece now also gets a texture. So I'm adding a texture here, and after the texture a desaturation and even some light colorization. So I color it a bit more brown. So this is the color that I want to see on the texture and on the particles. And how is this coming in? This is actually not the same mask that I use for the particles. I created a separate mask which moves in earlier and which moves in slightly different. So I have these soft boundaries here, which I don't want for the particles. I want this only for this mask. I have a soft mask here, and I can show you the mask. This is the mask, and it kind of starts with the arm, where also the particles will start. And then here it creeps in a bit from the side and over the shoulder. I thought that's maybe interesting. And I created this mask. This is a very simple mask, by the way. This is just like a shape like this and a shape like, I don't know, just a few very simple shapes. And I used these shapes on the original roto to put these smooth shapes over the original roto shapes. Now with this, I get this colorization effect. Colorization and texture. With the texture in place, I am using what we did before. I am slicing, taking out the slices frame by frame, which are creating the particles, and that is happening here. But this time on the darker colorized version. So I'm creating the particles already with the darker image here. But otherwise it works the same way as I did in the basic version. However, I am doing this not only once, I am doing this 2 times. And the second time here I have, or actually 3 times to be very precise. In the second time I am doing another different time delay. So this is like, what, 5 frames back, and this one here is based on, I think, 1 frame back. Let me check. 1 frame back, yeah. So the first one here, I create this stripe for 1 frame back. Then I go 5 frames back and create another stripe, and another one. No, sorry, this is the same, sorry. Okay, so I have my stripe in 2 different times, and the reason for this is the layering that I do at the end. So in 3D here, I am rendering my particles multiple times, and one set of particles here get transformed and being pushed into the back. And let me see if I can show that quickly to you. I have here my cut out foreground image, and here I currently don't see anything. So let me move a bit forward. Let me deactivate the particles, because otherwise the rendering time will take too long. Control P for pass through or deactivate is the shortcut. So I'm turning them off. And now I can move through, and I see, yeah, I should see myself turn dark and then being removed, but not only removed once, but I copied the time delayed image 1 layer back, turned it even darker, and put that into the background. So there is now something similar to the basic version, just with the colorization and the texture. And then a second copy of this, time delayed, behind and darker. And I'm using the second layer to create the bigger and darker particles. So I have small and brighter particles in the front, and then which are like peeling off, and I still have the background layer, which is then turning into the bigger particles. So this is why I have multiple particle systems. By the way, you could in principle put all into one. You can have different emitters in one particle system. The reason why I splitted it here is also for performance reasons, because I noticed that when I render a single particle stream with lots of particles, my CPU usage is still relatively low. So I don't think that, at least in the current beta version and where I'm testing here, I think there is not much of CPU parallelization in the particle system. So when I started creating different particles and so on, I just put it in completely separate streams. And now what Fusion, at least in the Studio standalone version, can do, it can render different branches here in parallel. So this way I use more CPU cores. That's the idea. But it has no impact on the effect itself. You could also merge everything together directly. Okay, and now of course the particles itself, I have an insane number. So here I have point particles, and I'm not turning that on now because it will just take time, but I'm starting out until here with 800 particles per frame which are being generated, and then I ramp it up basically at the point when I move from the arm to the whole body. I increase the number of particles. So of course the rotor shape that is cutting out the arm and so on is also a bit different than in the basic version. In the basic version I just used one rotor for all of it, and here in this version I first rotored out the arm, removed the arm, and then removed the rest. But the principle is still the same. So, but that's also why when I'm only removing the arm I use less particles, because the arm is smaller, and then I crank up the number of particles. Point particles here, then I have two types of n-gons, one smaller ones with 800 here, 2000 here, going up to 4000. And then at the end, the bigger particles for the background. I have also still, 100. Up to, okay, it increases up to 250. Now there's a lot of fine-tuning involved, and it does take quite a lot of hours to get to a point like this. This is also the reason why this tutorial didn't really come out when I thought it would come out, which was 2 weeks ago, and this is why my intro originally sounded like this. Hey guys, Avengers Endgame is coming into theaters this week, and then Avengers Endgame came out before my tutorial and I had to do ADR on my own tutorial. Avengers Endgame has come into theaters last week. Yeah, sometimes things take longer than planned, but I hope you enjoyed it overall. There are a lot of different versions which I made in between. For example, this one here, I tried using the particle image emitter. I didn't really like the look of the particles here, that's why I changed it later. Here is a version which I do only with one layer. There you have a bit less depth, but overall the idea is already here. Okay, for the end, maybe some lessons learned around this. If you decide to do a project like this, especially if it gets on larger scope, as I mentioned before, start with as little particles as you can get away with, just to get the overall animation right, get the overall feel right, frame length, and so on, and only then put up the number of particles. If you can separate it, for example, I can render only particles which are like the large background particles. I can render them separately. I can render the foreground particles separately, just to see how they look and get that right part by part, and then at the end put it together again, so I can work quicker in between. When it comes to rendering, you should have some workflow where you can render temporary versions out to disk. That really can save you in situations like this. If you're on Fusion standalone, you can use the saver nodes anyways, like always. Also, if you are inside DaVinci Resolve, there's still the saver node available, and you find under the Fusion menu, you find render savers. So you can still use that to directly render from Fusion onto disk. So you get then the DPX file sequence or whatever, and you can render it, take a coffee break, and 20 minutes later, or how long your render takes, you come back, load the sequence, and you can then, when you have the full sequence loaded into Fusion or into Resolve, you can jump back and forth in the timeline without waiting, and you can look at the whole thing. Maybe you try some color corrections on the final render just to see what you might want to apply to the particles or so. And then once you have an idea what you want to do next, you do everything you want to do next, change the particle numbers, change the the color, change the masks, whatever problems you find, and then you do the next render while having the next coffee break. Yeah, so no matter where you work, you should develop some workflow like this that you're comfortable with, and where you're not sitting in front of the computer waiting for 20 frames to render only to then change one particle parameter. Because remember, in particles, whenever you change one parameter, it has to go back and calculate from the beginning. Particles always go frame by frame, they move frame by frame. So if one force changes, it goes back and you have to render everything. And if you have the Fusion standalone version, I think this kind of complexity makes more sense in the standalone version, because there is the render manager, the loader and saver nodes are still fully functional and so on, and there's still some performance benefits of the standalone version that you may take advantage of. Okay, so much for this tutorial. Now, this was quite extensive and I touched based on a lot of different principles, tools and concepts. If there's anything in particular which you want to learn more about or which you want me to explain in detail, please let me know in the comments. I might do a few more particle tutorials, but then on more like individual focused aspects of it in the next couple of weeks. So stay tuned on this channel, subscribe, like, and let me know if there's anything in particular you want to see. And see you around next time.